Alright, so welcome class. We're going to try and do our first video lesson. First time I've done this, so please be kind to me. So today we're going to look at naming alkenes, alkanes and alkynes. These are our hydrocarbons. So they only contain carbon and hydrogen in the molecule. Now these are three homologous series, so they are each alkane, alkene and alkyne has the same general formula, and we'll go through and see what this means. But essentially alkanes are hydrocarbons that contain only single carbon-carbon bonds. So for example, let's draw ethane. I have a single carbon-carbon bond, and of course remember each carbon has to have 4 bonds to it because it has a valency of 4. I can then put in 3 hydrogens. You may remember doing this from Lewis dot structures, and this is the structure of ethane. Let's check the general formula. We have 2 carbons, so C2. Now to predict the hydrogens, 2n plus 2 is 6, and indeed you can see we have 6 hydrogens. That's ethane. Now, of course, we can have a hydrocarbon that has a double bond, a double carbon-carbon bond. So let's remove these hydrogens for the moment. We're going to put in a double bond, and then to satisfy the valency of carbon, being 4, I can then only put 2 hydrogens bonded to each carbon atom, and now we have ethene. Ethene. Let's just examine the name for a moment. Ethene, we have the first part of the name, eth, and the second part of the name, ene. Now this second part comes from the root of the homologous series name, alkenes. The first part comes from that series of prefixes which I got you to remember, meth, eth, prop, but, etc. Eth being 2 carbons, so this is 2 carbon, double bond, ethene. Ethane, of course, where we have our single bond, we likewise write eth, but the suffix this time is going to be ane or ethane. Okay, so ethyne, triple bond. As we can see, to make a triple bond from this, we have to remove 2 hydrogens, and that's why the general formula is now not CnH2n for an alkyne, but is going to be 2 hydrogens less. So let's draw that structure. So we start with our 2 carbons. We have a triple bond. Remember, each carbon wants to have 8 electrons around it. So it currently has 6 because they're sharing. I can now only put 1 hydrogen onto each carbon to satisfy the octet rule. And this we're now going to name ethyne. Eth for the 2, and ine from the root of the name of the class of hydrocarbon, ethyne. And if we add up our formula here, 2 carbons, C2, 2n, okay, 4, but minus 2, which gives us 2 hydrogens in the end, ethyne. Okay, so naming these straight chain hydrocarbons is pretty trivial. Let's give you an example. Let's draw and name the structure for the formula C6H12. Now before we begin, we can have a quick look at our 3 general formulas, and we can actually predict which class of compound this hydrocarbon is going to belong to. C6, double that, we get 12, and we can see straight away it's going to be an alkene. So let's start. We draw 6 carbons, all bonded to each other, and 6. We now have to put in our hydrogens. We can do that a number of different ways, so let's start with these inner ones. Now, if you count these hydrogens, as I'm sure you're doing at home, you'll see that this isn't actually the formula C6H12, it's C6H14. This is the alkane. What will we name this? Count the carbons, 6. So the prefix is hex, and the suffix is ane because it's an alkane, hexane. All right, but we want to have hexene. So what we need to do to convert an alkane to an alkene, we need to lose 2 hydrogens. Now, this can be done a number of different ways. The 2 hydrogens have to be on adjacent carbons, of course, because we want to end up with a double bond between 2 carbons. So let's make it easy. Let's take out this hydrogen and this hydrogen. I now put in a double bond. Check that this carbon has 4 bonds to it, yes. This one has 4 bonds to it, yes. And we've got the right formula now. And let's name it. So like the hexane, it's going to be hex. But we're now going to name it ENE, hexene. All right, let's do the same thing with the alkyne. So first of all, we have to change our formula. Take away 2 more hydrogens. C6H10, which is 12 minus 2, so that's 10. It follows the general formula. I now remove 2 more hydrogens in the structural formula. And to name this, it is hex. Ine, hex for 6 carbons, YNE or ine for a triple bond, hexine. Now, there's a couple of problems here. I took away hydrogens on these first 2 carbons, but what would happen if I had taken them away from carbon 2 and carbon 3 instead? I now have a completely new compound, so we need a new way to name that to reflect the position of that triple bond. So this is where we introduce numbering the longest chain. So we number it in such a way that one of the carbons with the triple bond is the lowest number. So in this case, 1, 2, 3. Our triple bond starts on the second carbon, and so we can now call this. There's a couple of ways of doing this. I'll show you the old way that I'm used to. You will come across this all the time on the internet and other sources, but there's a new way of naming it, which you have to do for the HSC now. Instead of putting 2 out the front, it's hex 2 INE with dashes between the 2 and the names. This is hex 2-ine. Okay, I'm going to get you to do the next one. Let's remove that. Make it back to a single bond. Take away this one. And I'll get you to have a go at naming that for me. I'll give you a couple of minutes. Okay, if you want longer, press the pause button. All right, let's label this. 1, 2, 3. So from this end, 1, 2, 3, until I get to the double bond. Let's check the other end. Maybe I can get a smaller number. 1, 2, 3. So because hexane or hexene is symmetrical, I can turn it 180 degrees without breaking any bonds. It doesn't matter which end of the chain I count from. I still get 3 being the number the double bond starts from. And so the name of this will be hex for 6 carbons dash 3 ENE to tell us it's a double bond hex 3 ene. Okay, I'll show you one last thing, and that will help you finish that homework sheet that I put on Google Classrooms. Let's say we have a branched alkane. So if you remember, with the branched alkanes, we've removed one of the hydrogens. Make it a bit clearer. And we put an alkyl group or a branch, in this case a methyl group. Only one carbon in the branch, a methyl group. Now we need to be careful when we're naming branch compounds. If you remember from our work on alkanes, we need to make sure we still start with the longest chain. So let's count 1, 2, 3, 4, 5, 6. That's a hexane chain. 1, 2, 3, 4, 5, 6. So it doesn't matter in this case which branch we take. If I had it made, and let's do it, this an ethyl group, this has actually changed where the longest chain is. So we now have 1, 2, 3, 4, 5, 6, 7. And so this has now changed from a hexene to a heptene, 7. And so when we're trying to number where the double bond is, we now have to count along our 7-membered chain. So let's try from this end. 1, 2, 3. 1, 2, 3, 4. So we're going to number from this carbon. 1, 2, 3. And so we know this is going to be a heptene, and it's going to be a 3-heptene. So hept, 3-ene, but we now have a branch. In this case, the branch is now over here. And which carbon is it on? We have to keep numbering. Once we number a carbon, you start with these by numbering the lowest number to get the double bond first, that takes precedence. Then you number branches using the same system. So in this system, 1, 2, 3, 4, 5. 5 is where our methyl group is. And so we now write 5-methyl hept 3-ene. Okay, so have a go at the examples in the textbook. Have a go at that homework sheet. Please make sure you take a picture of your efforts, send it to me so I can give you feedback whether you're right or wrong. Okay, we'll catch up again soon, and I'm sure I'll get better at these videos as we go along. All right, good luck everyone. See you soon.